Howdy, we are the Theft ID Assist team composed of Diana Wallison, Stephanie Demko, Christopher Horn, Christopher McNally Durkin, and myself, Caleb Hawley. As the name suggests, we are a theft preventing project designed to capture and analyze license plate data of vehicles entering or exiting certain parking lots around the Texas A&M University campus. This data will then be used by the Texas A&M University Police Department to track stolen vehicles and obtain information about these vehicles in a certain parking lot. Looking at the photo shown, you can see how the system operates. The system is powered by two rechargeable batteries that are capable of supplying all the needed power for the many different components. Two cameras, a day and night camera, capture images of vehicle license plates as they enter or exit a lot. This is accomplished via a motion sensing algorithm, which utilizes the cameras to detect motion in their field of view. After an image is captured, it is then transmitted via XP modules to a secondary system located in a nearby building with access to an internet connection, which then receives these images and stores them for analytics to be run. From here, optical character recognition software, or OCR for short, is run on the images to obtain the license plate information and is then stored in the database for analysis, which is where the user would begin to see the end result of the system. As stated previously, the power to run the Theft ID Assist system is supplied from two 6-volt 33 amp hour batteries combined in parallel to obtain a 66 amp hour capacity. A charge indicator is attached to the terminals of the battery to indicate the remaining battery life. Due to the 5-volt input requirement of the microcontroller, a DC to DC step-down buck converter steps down the 6-volt output of the battery to the required 5 volts. From here, all other components plug into the Raspberry Pi and are powered from their respective ports. The estimated life of the system is estimated to be 5 days, 8 hours based on current consumption measurements. But with the estimated downtime during the early morning hours and weekends, we estimate the life to be well over the 7-day requirement.
The day camera subsystem operates between an hour before sunrise and an hour after sunset. When a car is detected by the camera, 3 images are taken at 1-second intervals. To ensure at least one readable license plate, the images are sharpened using Gaussian blur. Then, to minimize the file sizes, the images are cropped. 40% of the top and the right side are removed. Lastly, the images are saved as JPEGs, with the name being the time and date.
The night camera subsystem operates between an hour before sunset and an hour after sunrise. The camera captures 4 images when a car is detected, then removes the blurriest image for a total of 3 photos. The images are then filtered to dim the brightness of rear lights using a mask and sharpened using Gaussian blur to increase the likelihood of the OCR program correctly reading the license plate. The 3 images are then saved as JPEGs to the transmission folder using the timestamp as the file name.
The control subsystem establishes the channel of communication between the image capture subsystem and the image processing subsystem. The subsystem is made up of 2 XP Pro 900 HP modules and 2 Raspberry Pi 3Bs. It uses the XP Digimesh networking protocol to transfer images from one Raspberry Pi to the other. It does this by breaking down the files and the packets on the sending end and recreating the files from parsed packets on the receiving end. The XPs are configured in API mode to ensure successful transmission of data. Lastly, the pictures at the receiving end are transferred to the image processing subsystem via Wi-Fi.
The image processing subsystem receives images from the Pi in groups of 3. For each group of images, the system will run OCR analysis on each image. The image that returns the highest confidence interval will be added to the database. The other 2 will be stored in a backup location. In the event that no image on the group is read, the first image will be added to the database. Each row of the database contains the image, the timestamp, and the image confidence interval.
In summary, the system is able to capture images of license plates when motion is detected, recording the time and date of the image, then transmitting the images wirelessly to the user-friendly database, where image processing and analysis is performed to obtain the end result of the system. In addition, the Theft ID Assist system is inconspicuous due to the small and common size enclosure, portable, weighing just over 33 pounds, long-lasting, having an estimated battery life of 7+ days, weatherproof due to the sealed tight fitting enclosure able to withstand all weather conditions, and hassle-free with the initial setup and implementation able to initialize on startup. All in all, the final product met all the requirements set, allowing our team to apply and implement several concepts and skills learned throughout our time at Texas A&M.
What you gonna do? What you gonna do when they come for you? Bad boys, what you gonna do?